Why is power factor correction essential for energy savings? Have you ever wondered why power factor correction is so important for saving energy? Let's break it down in a way that makes sense. Power factor correction, or PFC, is all about improving how efficiently electrical power is used. It helps reduce the amount of reactive power in a system. Reactive power does not do any useful work, yet it still needs to be generated and transmitted. This can lead to energy losses and increased demand on the power supply. When we correct the power factor, we aim to bring it closer to unity, which is a value of 1. This means the system can use electrical power more effectively, cutting down on wasted energy and lowering electricity costs. In simple terms, power factor is the ratio of active power, which does useful work, to apparent power, which is the total power supplied, including both active and reactive components. If the power factor is low, more current is needed to deliver the same amount of useful power. This causes higher losses in cables, transformers, and other equipment because of increased heat. This inefficiency results in higher energy consumption and increased operational costs. To correct the power factor, we typically add capacitors or capacitor banks to the electrical system. These capacitors provide reactive power locally, offsetting inductive loads like motors and transformers that cause the current to lag behind the voltage. This compensation reduces the reactive power drawn from the grid, lowering the total current flow and minimizing energy losses in the distribution system. From the perspective of power generation and transmission, improving the power factor has several benefits. It decreases the load on generators and transformers, which can extend their lifespan and reduce maintenance costs. It also lowers transmission losses since less current is needed for the same delivery of active power. Moreover, correcting the power factor helps avoid utility penalties. Many electricity providers charge extra fees for customers with low power factors, typically below 0.9. In practical applications, power factor correction devices are installed close to the inductive loads they compensate for or centrally for groups of loads, depending on the system design and economic factors. This localized correction minimizes unnecessary current circulation and improves voltage stability. Overall, power factor correction is a fundamental practice in electrical engineering that boosts energy efficiency, cuts operational costs, and supports reliable power system operation. By understanding and implementing power factor correction, we can make a significant impact on energy savings and sustainability in power systems and renewable energy.